Hello dear students, how are you? Today we are going to discuss about Homo and Lumo. Right? This is very important topic, so watch the video till end. Right? So let us start. First, I will tell you what is Homo. Homo means highest occupied molecular orbital. Right? Homo means highest occupied molecular orbital, and Lumo means lowest unoccupied molecular orbital. To understand Homo and Lumo, I take example of hexa 135 triene, right? This is hexa 135 triene, right? We can write this one like this. Right? We can write hexa 135 triene like this also. Okay? In hexa 135 triene, there are 3 pi bonds, right? 1 pi bond. This is first pi bond, second pi bond, third pi bond. Means there are 3 pi bonds, and each made up of 2 p orbitals, right? There are 3 pi bonds, each made up of 2 p orbitals. It means 6 atomic orbitals are there. So we expect 6 molecular orbitals. Right? I once again repeat, in hexa 135 triene, there are 3 pi bonds, each made up of 2 p orbitals. So there are 6 atomic orbitals. We expect 6 molecular orbitals, right? There is a simple trick. In hexa 135 triene, there are 6 carbon atoms, right? This is a simple trick and you can follow this trick. In hexa 135 triene, there are 6 carbon atoms, right? So we can expect 6 molecular orbitals, and there are 6 electrons, right? If there are 4 carbon atoms, we expect 4 molecular orbitals, and there are 4 electrons, right? Here 6 molecular orbitals are psi 1, psi 2, psi 3, psi 4, psi 5, and psi 6. These are 6 molecular orbitals, right? Now let us draw these molecular orbitals. These are 6 molecular orbitals. This one is psi 1, this is psi 2, this is psi 3, this is psi 4, this is psi 5, and this is psi 6. Right? These are 6 molecular orbitals. Now we see number of nodes. For this I have a formula. This is psi n minus 1. Right? So in this case psi n is 6 minus 1. Right? In this case n is 6 minus 1. It means there are 5 nodes. Here n is 5 minus 1. 4 nodes. 4 minus 1. 3 nodes. 3 minus 1. 2 nodes. 2 minus 1. 1 node. 1 minus 1. 0 node. Right? To calculate nodes you can use this formula. Right? In psi 1 there is no node. Right? In psi 2 there is one node. Right? Node is when two lobes have different sign. It means there is node between these lobes. Right? These are two lobes and these lobes have different sign, so there is one node. Right? Now psi 3 there are same lobes, so no node. Different lobes, so one node is there. Same lobe, no node. Different lobes, one node, so two nodes. Right? This one and this one. Different lobes, one node. Same lobes, no node. Different lobes, one node. Same lobes, no node. Different lobes, one node. So three nodes are there. Same is the case here. One node. Right? Different lobes, one node. Different lobes, one node. Right? Same lobe, no node. Different lobes, one node. Then different lobes, one node. So four nodes. 1, 2, 3, 4. Different lobes, one node. Different lobes, one node. And then different lobes, one node. Then different lobes, one node. Different lobes, one node. So there are 5 nodes. Right? Now in psi 1 last two lobes have same sign, so this is symmetric. ठीक है? In psi 2 last two lobes have different sign, so this is asymmetric, right? Then again same sign, symmetric, right? Then again this lobe and this lobe have different sign, then this is asymmetric, same sign, symmetric, last two lobes have different sign, so asymmetric, right? Psi 1 is symmetric, psi 2 is asymmetric, psi 3 is symmetric, psi 4 is asymmetric, psi 5 is symmetric, and psi 6 is asymmetric, right? Now there are 6 electrons. First we talk about thermal condition, right? First we talk about thermal condition. 6 electrons we can fill here. 2 electrons, 2 electrons, 2 electrons, right? These are 3 orbitals, means psi 1, psi 2 and psi 3. These are orbitals in which there are electrons. These are occupied molecular orbitals, right? This is lower occupied molecular orbital and this is highest occupied molecular orbital. So for thermal conditions this is HOMO, right? For thermal conditions psi 3 is HOMO, right? Once again I repeat, these are 3 orbitals which have electrons. This is highest occupied molecular orbital and this is lowest occupied molecular orbital, means this is orbital which have electrons, highest molecular orbital. Then these are 3 orbitals, psi 4, psi 5 and psi 6, which don't have any electrons, right? So this is LUMO. Psi 4 is LUMO for thermal conditions, right? I once again repeat, these 3 orbitals psi 4, psi 5 and psi 6 don't have any electrons. So psi 4 is lowest unoccupied molecular orbital and psi 6 is highest unoccupied molecular orbital, right? Now if we talk about thermal conditions, now we talk about photochemical conditions. In photochemical conditions, let us fill electrons. Now in photochemical conditions, one electron from psi 3 jump to psi 4, right? Now what happens? Psi 4 is HOMO, right? In thermal conditions psi 3 is HOMO because psi 3 has electrons, but in photochemical reactions psi 4 is HOMO. Now these 4 orbitals have electrons, right? And psi 4 is the highest occupied molecular orbital, means this is highest orbital which have electrons. So psi4 is HOMO for photochemical conditions, right? Now in this case these two orbitals don't have any electrons, right? So for photochemical reactions psi5 is LUMO, right? I once again repeat, for thermal conditions psi3 is HOMO and psi4 is LUMO, but in photochemical conditions one electron from psi3 jumped to psi4. Now psi4 is HOMO, right? And psi5 is LUMO because these are four orbitals which have electrons. This is highest occupied molecular orbital and this is lowest occupied molecular orbital. These two orbitals don't have any electrons in case of photochemical reactions. So this is lowest unoccupied orbital and this is highest unoccupied molecular orbital. We can say that for thermal conditions psi3 is HOMO and psi4 is LUMO. And in case of photochemical reactions psi4 is HOMO and psi5 is LUMO, right guys? So this is all about HOMO and LUMO. I hope you understand.